Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So let's have more factoring. X cubed plus y cubed. This is the sum of two cubes. We have cube root of the first plus cube root of the second. Then the other factor is a trinomial, which is the square of the first minus the product, then the square of the second. Difference of two cubes, cube root of the first minus cube root of the second. Then the other factor consists of trinomials, and it is the square of the first plus the product, and product of x and y is xy, then the square of the second, y square. Then we have perfect square trinomial, x squared plus 2xy plus y square. Take note that this is twice the square root of x square and y square. So 2 times square root of x square is x, square root of y square is y, so 2xy. And to completely factor it, it is x plus y quantity square. Likewise, we have x squared minus 2xy plus y square. So we have minus twice the square root of the first and the last. So it is quantity x minus y quantity square. So again, uh, take note that this is a perfect square trinomial. First and last are perfect squares, although there are expressions which are not arranged in this manner, but you have to quickly recognize that it is, or the given trinomial is a perfect square trinomial in factoring methods. So there are expressions really intentionally written in that manner, not arranged in this manner, but we have to quickly interpret that it is a perfect square trinomial. So these are the exercises. Factor the following completely. Insert any missing term to complete a square, and factor for some exercises here, like part F, we have missing term, part G and part H. So for this is for your part. So for part A, this is a perfect square, perfect square. Square root of a square is a, square root of 4 is 2. Their product is 2a times 2, so negative 4a. So this is a perfect square trinomial. Since this is negative, the complete factored form would be quantity a minus 2 square. Quantity a minus 2 square. 9x to the fourth is a perfect square. Square root is 3x squared. 1 is a perfect square. Square root is 1. 3x squared times 1 is 3x squared times 2, 6x squared. Since this is negative, the complete factored form would be quantity 3x squared minus 1, or open parenthesis 3x squared minus 1 close square. So we cannot factor this anymore because 3 is not a perfect square. 4x squared is a perfect square. 9w squared is a perfect square. Square root of 4x squared is 2x. Square root of 9w squared is 3w. 2x times 3w is 6wx times 2, 12wx, which is this. And since this is negative, the complete factored form would be quantity 2x minus 3w close square. Perfect square, a square, 49b square is a perfect square. Square root of a square is a. Square root of 49b square is 7b. A times 7b is 7ab times 2, 14ab. Since this is negative, so the complete factored form is open quantity a minus 7b close square. 25z square is a perfect square. 196u square is a perfect square. Square root of 25z square is 5z. Square root of 196u square is 14u. 5z times 14u is 70uz times 2, so 140uz. Since this is negative, the complete factored form is open quantity 5z minus 14u close square. So 5z minus 14u close square. So in this case, x square is a perfect square, 36 is a perfect square, square root of x square is x, square root of 36 is 6, the product is 6x times 2, 12x. So the missing term here is 12x. Since this is plus, the complete factored form is quantity x plus 6 close square. This is a perfect square. The square root is y. Perfect square, the square root is 9. Y times 9, 9y times 2, 18y. So minus, so the missing term is 18y here. And write this as y squared minus 18y plus 81. The complete factored form is open quantity y minus 9 close square. 16u square is a perfect square. Square root is 4u. 49y square is a perfect square. The square root is 7y. 4u times 7y is 28uy times 2, 56uy. So minus, the missing term here is 56uy. And this is a perfect square trinomial. The complete factored form is open quantity 4u minus 7y close square. 4u minus 7y square. X square is a perfect square. Square root of x square is x. 1/4 is a perfect square. The square root is 1/2. X times 1/2 is 1/2 x times 2 is x or 1x or x. So therefore, this is a perfect square trinomial. We write this in factored form as x plus 1/2 close square. Quantity x plus 1/2 close quantity square. 4x to the 4th is a perfect square. The square root is 2x squared. 49 is a perfect square. The square root is 7. So 2x squared times 7, 14x squared times 2, 28x squared. So it is this. It guarantees this part here. So therefore, the complete factored form is open quantity 2x squared minus 7 close square. 2x squared minus 7 close square. X squared is a perfect square trinomial. This is for your part. 25y to the 4th is a perfect square. Show that the answer is, the complete factor form is x minus 5y squared quantity square. This part show that it is 3u squared plus 4a quantity square, and show that the missing term here is 6x, and show that the factored form is quantity 3x minus 1 close square. For the second batch, factor the following completely. So we have so many exercises, and you also have your part here. So of course the solution will not fit in this slide, so some of the problems will be presented on the next slide. So 16x to the 4th is a perfect square. 81y to the 4th is a perfect square. Therefore, the square root is 4x squared, 9y squared. The product 4x squared times 9y squared is 36x squared y squared times 2, so 72x squared y squared. So this is a perfect square trinomial written in the form 4x squared minus 9y squared, quantity, open quantity 4x squared minus 9y squared, close, then square. And since 4x squared minus 9y squared is difference of two squares, we can write this as 2x quantity square minus 3y quantity square. So we factor this part inside as quantity 2x plus 3y, then quantity 2x minus 3y, then the whole is raised to 2. So therefore, the complete factored form is 2x plus 3y quantity square, then times quantity 2x minus 3y quantity square. So all terms are negative. If we factor out negative, then we'll have 9u square plus 100w to the fourth, then plus 60uw square, or negative quantity 9u square plus 60uw square, then plus 100w to the fourth. Square root of 9u square is 3u, square root of 100w to the fourth is 10 w square, so 3u times 10w square is 30 uw square times 2, which is this. So therefore, the complete factored form is negative of quantity 3u plus 10w square close quantity square. So negative of quantity 3u plus 10w square close quantity square. So that's the complete factored form. This is difference of 2 cubes, y cube minus 3 cube. So one factor would be quantity y minus 3, and the other factor would be the square of y squared, then product 3y, then plus the square of 3, 9. That's the factored form. This is again sum of 2 cubes, 1 cube plus quantity xy cube. So the first factor is quantity 1 plus xy, then the second factor consists of trinomial terms. So three terms. The first is the square of 1, which is 1. The second is minus the product, so minus xy. And the last one is the square of xy, which is x square y square. So therefore, this is quantity 1 plus xy times quantity 1 minus xy plus x square rather. X square y square. Or the square of xy. So square of 1 minus their product, so minus xy, then the square of xy plus x square y square. This is 10 cube minus x cube. So the factors would be 10 minus x, then the other factor would be the square of 10, 100, then their plus their product 10x, then the square of x, x square. So this is quantity 10 minus x times open quantity 100 plus 10x plus x square. This is sum of 2 cubes, 5x quantity cube plus 2y quantity cube. So the first factor is 5x plus 2y. The other factor would be trinomial. So the square of 5x is open quantity 25x square minus their product. So minus 10xy. Then plus the square of 2y, so plus 4y square. So that's it. This is sum of 2 cubes, 4a quantity cube plus 3b quantity cube. So the first factor is a binomial, 4a plus 3b. Then the other factor is a trinomial. The square of 4a is 16a square minus their product, so minus 12ab. Then plus the square of 3b, which is 9b square. This one is difference of 2 cubes. So 5a square quantity cube minus 2u square quantity cube. So the binomial terms of the first factor would be 5a square minus 2u square. Then the other factor would be trinomial, the square of 5a square, 25a to the fourth. Then plus their product, 10a square u square. Then the square of 2u square plus 4u to the fourth. Then this one is difference of 2 squares, y square quantity square minus 9 square. to the fourth minus 9 square, or y square quantity square minus 9 square. So we write this as y square plus 9, then quantity y square minus 9. So this cannot be factored anymore, but y square minus 9 is difference of two squares. The factors are y plus 3 and y minus 3. So the complete factored form is quantity y square plus 9, then quantity y plus 3, y minus 3. This is sum of two cubes, x square quantity cube plus 1 cube. So the first factor will be quantity x square plus 1, and the other factor, which is a trinomial, is the square of x square is x to the fourth, then minus their product minus x square, and plus the square of 1, which is plus 1. So that's the complete factored form. This is difference of two cubes. You can also write this as difference of two squares. So I'll present two solutions to this, and the answer should be the same. First, difference of two cubes. We write this as 9 cube minus a square quantity cube, or 9 minus a squared. That's the first factor. Then the other factor is square of 981 plus their product 9a squared, then plus the square of a squared, a to the fourth. Then this is difference of two squares. This one can be made perfect square trinomial. The middle term should be 18, and since to make this 18, we should add 9a square, and 9a square is a perfect square trinomial, so we should also subtract 9a square. We'll make this difference of two squares. So we write this first as quantity 9 minus a square, then this one 81 plus 18a square plus a to the fourth, then minus 9a square. So this is a perfect square trinomial, which is 9 plus a square quantity square, then minus 3a quantity square. So this is difference of two squares also, 3 square minus a square. So this is quantity 3 plus a, then 3 minus a, then quantity 9 plus a square quantity square, then minus 3a quantity square. So another difference of two squares. So equals quantity 3 plus a times 3 minus a, then we have 9 plus a square plus 3a, then times 9 plus a square minus 3a. So that's the complete factored form. We may also arrange this as a square plus 3a plus 9 and a square minus 3a plus 9, but let's just leave the answer in that manner. Now, what if we interpret this as difference of two squares, 27 square minus a cube quantity square? So 27 square minus a cube quantity square, so difference of two squares. This is therefore 27 plus a cube, then times 27 minus a cube. And 27 plus a cube is sum of two cubes, 3 cube plus a cube. 27 minus a cube is difference of two cubes, 3 cube minus a cube. Then for the first sum of two cubes, the factors are 3 plus a, and the other factor would be square of 3, which is 9, minus their product 3a, then square of a square. So 9 minus 3a plus a square. Likewise, this one is 3 minus a, and the other factors would be quantity 9 plus product plus 3a, then plus a square. So which is, if you notice, these factors are similar to that. So therefore, we copy this answer. So 3 plus a, 3 minus a, quantity 9 plus a square plus 3a, then times quantity 9 plus a square minus 3a. So for part M, since we run out of space, let's have that on the next slide. So let's continue. part m, x to the 16 minus y to the 16, then n, 64 plus x to the 6, y to the 6, o, 256 minus x to the 8, then your part here. So for part m, we remember that difference of two squares must be the first thing to do or control. So we write this as x quantity x to the 8 square minus y to the 8 quantity square. And since we have difference of two squares, factors are quantity x to the 8 plus y to the 8, then quantity x to the 8 minus y to the 8. So remember, with our experience, this is already prime. We can no longer factor this unless the exponents are prime, where we can still factor that. Since these are already prime and this one is difference of two squares, we write this as quantity x to the fourth square minus y to the fourth quantity square. So x to the 8 plus y to the 8 times quantity x to the fourth quantity square minus y to the fourth quantity square. So we have difference of two squares again. So copy x to the 8 plus y to the 8 times quantity x to the fourth plus y to the fourth, then quantity x to the fourth minus y to the fourth. So x to the fourth plus y to the fourth is another expression that is prime. We can no longer factor this, but we have x to the fourth minus y to the fourth, which is difference of two squares, which we can still factor. So therefore, copy x to the 8 plus y to the 8 times open quantity x to the fourth plus y to the fourth. Then this is x squared plus y squared, x squared quantity square minus y squared quantity square. So copy x to the 8 plus y to the 8 times x to the fourth plus y to the fourth. Then we'll have x squared plus y squared, then times quantity x squared minus y squared. So we cannot factor x squared plus y squared also, just like this. But x squared minus y squared is difference of two squares. Therefore, the final and complete factored form of x to the 16 minus y to the 16 is we copy quantity x to the 8 plus y to the 8 closed, open quantity x to the 4 plus y to the 4 closed, open quantity x squared plus y squared closed, then quantity x plus y, x minus y. So that's the complete factored form of x to the 16 minus y to the 16. This is sum of two cubes, 4 cube plus x square y square quantity cube, 4 cube plus x square y square quantity cube. So the first factor of the binomial would be 4 plus x square y square. Then the other factors would be quantity square of 4, which is 16. Then minus their product, minus 4x square y square, and the square of x or y square plus x to the fourth, y to the fourth. Though these are perfect squares, square root of 16, 4, square root of x square y square, x to the fourth, y to the fourth is x square y square, then their product 4x square y square times 2, so 8x square y square. So the missing term here is negative 8, but we add 4x square y square, perfect square, but that becomes sum of two squares. We cannot factor that anymore, so that's why this is the complete factored form of this expression. This is difference of two squares, 2 to the 8 minus x to the 8. So 16 square minus x to the fourth square, or 2 to the 8 minus x to the fourth, or x to the 8, which is written x to the fourth quantity square. So we'll begin with 16 square, which is 256 minus x to the fourth quantity square. Difference of two squares, we have quantity 16 plus x to the fourth and quantity 16 minus x to the fourth. So this is difference of two squares. This one is prime, relatively prime. We cannot factor that anymore. So we copy 16 plus x to the fourth, then we write this as 4 square minus x square quantity square. So furthermore, this is quantity 16 plus x to the fourth times quantity 4 plus x square, then open quantity 4 minus x square. We have difference of two squares. Factors of this are 2 plus x and 2 minus x. 4 plus x squared can no longer be factored, that's prime. So therefore, the final answer would be quantity 16 plus x to the fourth times open quantity 4 plus x squared, quantity 2 plus x, then 2 minus x. Then for your part, show that the complete factored form for part B is equal to x plus 2y, then open quantity x minus 2y, open quantity x squared plus 2xy plus 4y squared, then open quantity x squared minus 2xy plus 4y squared. Then Q, show that this is 25 plus 4x squared, open quantity 5 minus 2x squared, open quantity 5 plus 2x squared. Then this one, show that this is 2a minus 3x squared, open quantity 4a squared plus 6a squared, 6ax squared plus 9x to the fourth. Then finally, for this part, show that the complete factored form is quantity a plus b, quantity a squared minus ab plus b squared, and quantity a to the 6 minus a cubed b cubed, then plus b to the 6. So show that that's the complete factored form. So that's it, and I hope that you will also do your part here.